Methane research is really important for two reasons. The first is that methane is a greenhouse gas and it is 25 times more potent than carbon dioxide. We know that roughly 10% of Australia's greenhouse gas is from digestion in ruminants. And it's a cost to the ruminant as well, that somewhere like 2 to 12%, more commonly 6 to 10% of the energy that is digested by ruminants is lost as methane and can't be used for productivity. Well, the key findings from the National Livestock Methane Program is the breaking of a myth or a commonly held view before. And that view was that you couldn't reduce methane production in a ruminant without having a negative impact on productivity. And what we've found is that you can reduce methane by up to 90% and have a positive impact on productivity. There are 4 practices that have come out of the National Livestock Methane Program that can be applied by producers right now. First is Lukina in the north for cattle, improves productivity by roughly 20 to 25% and reduces methane by 20%, so it's a gain both ways. Shrubs in Western Australia, these are Australian native shrubs that have bioactive material in them, and if these are fed during the period of the autumn feed gap, particularly in southern and western Australia, then we found that we can reduce methane over a period by up to 20% and increase productivity, almost double productivity during that time. And so if you look over a whole year, you've got a reduction in methane of 4 to 5% and much less use of grain as a supplementary feed. There is Greatmark. Greatmark has tannins and other components in it that reduce methane. If it is fed as a drought feed or during periods of maintenance or replacing a feed with similar quality, it can reduce methane by about 10% without changing productivity. And the fourth one is feeding high levels of wheat to dairy cows at pasture. It's been found that if you feed 9 kilograms of wheat, half in the morning, half in the afternoon, will reduce methane by 30 to 50%, and for animals on pasture, increase milk yield by about 20%. There are a number of practices that are not far down the line, but need a little bit of extra work to bring them to fruition, and the most exciting one is red algae. It's been shown that a red algae that grows off the coast of Australia will reduce methane in sheep by over 80% and improve productivity, may improve growth rate by about 10%. At the moment, it's very costly because of the way it's got to be harvested, but it can be grown commercially on ropes like other algae around the world, and if it was grown particularly in association with aquaculture, it will potentially use the nutrients from there and reduce pollution. Already commercial companies are working on that. In about 3 to 4 years we will know whether that can be practiced, and if so, it's only fed at very low percentages like 2 to 3% of the diet, and potentially could be offered to all the ruminants around Australia. The next major areas are really working further in our understanding of how to manipulate the rumen and make more of the energy go through to productivity. And we know lots of ways in which that can be done, but they need to be worked through to get practical application. Vaccination is clearly an area that we need to work, because vaccines are very effective. You only give them once or twice and then you have a lifetime impact. And the aim is to vaccinate against the organisms that produce methane. It is not quite that easy because you need to build up a large number of antibodies within the stomach that don't get digested, but there are new techniques to be able to do that. And the other area that is really important is plant selection. We know that there are lots of plants that have differences in individual growing capacity and in their ability to reduce methane. And the idea is to be able to select these plants for niches where there are feed gaps, but at the same time reducing methane. The other big breakthroughs in the program were that a completely new organism has been discovered, never known before, and it has a different pathway, never known before, and this particular pathway is very efficient at taking hydrogen and producing methane. But luckily we understand more about the conversion of hydrogen through to methane, and we know that we can stop the very last step in that, which will then stop all of the pathways through to methane production, which gives us a real opportunity to almost eliminate methane production if we can block that pathway. The two important reasons to keep investing in this area is firstly just to make sure that those that are now there or nearly there have the information that can be used for farmers to be able to claim carbon credits so that they become methodologies. The second, though, is that we have a real opportunity to capture much more energy and reduce methane, which is good for the environment, but also good for the animal. And so those opportunities, if we can get 10% of that energy that's lost being captured and used for productivity, is fantastic for producers.